Hello, ladies and gentlemen, and thank you for listening to Mr. Laxton's video on this Chapter 3 practice test today. So that is what we are working on. So let me see if I can get my pen out here, my right one. All right, the first one asks us to solve by substitution here. So if I ask to solve by substitution, I need to plug whatever this is equal to in for x, because it's x equals this 4y minus 17. So I plug that guy in, and I'm going to find out what I get out. So if I plug that guy in here, let's take a look. I'm going to have 2 times 4y minus 17 minus 3y equals negative 9. All right, now I have one equation with one variable and just my y's. So I can distribute this guy. So now I get 8y minus 34 minus 3y is equal to negative 9. All right, I can add that 34 over and combine my like terms in the same step here. So I minus 34 to this, or add 34 to this side, excuse me. So now these guys combine to be 5y is equal to negative 9 plus 34 is 25. Should get y is equal to 5 here. All right, so that's my first part. Now to find out what my x is, I got to plug that guy back in. So it's easiest, this guy shoots x right out. So I get x equals 4 times 5. I'm plugging in my 5 for my y, minus 17. I get x is equal to 20 minus 17. So x is equal to 3. All right, final answer here is 3 comma 5. Make sure you give it to me in that form, please. All right, keep going here. Solve by elimination. This one, let's find some orange here for this guy. I need to create opposites here for this one. Create opposites. All right. So here, creating opposites, I look at this 2y and this negative 4y. I'm going to multiply this top equation by a positive 2 to create opposites here. So if I multiply this into everything here, I get 4x plus 4y is equal to 2 times 16 is 32. Once I have opposites, I can add straight down. These guys cancel each other out. That's the opposites that I wanted to create. Now this makes 7x is equal to negative 25 plus 32 is actually 7. So divide by 7, I get x equals 1. All right, so great, you found your x is equal to 1, but now you have to find out what your y is. So you can plug this x in here to solve for your y here. So I have 2 times 1 plus 2y is equal to 16. All right, I'm going to subtract this 2 over the other side because 2 times 1 is 2. I get 2y is equal to 14. Divide by 2, I get y is equal to 7. All right, final answer here is going to be x comma y, so it's 1 comma 7, done. All right, so these two lines, if you were to graph this line and this line, they would intersect at 1, 7. All right, looking at number 3, the word problem is what we have here. Going through the word problem, I always like to just circle my numbers. I know I'm going to need to use them. All right, so I'll give you guys a chance to read that, but we're dealing with two things. We're dealing with students and adults. All right, that's what my x and my y is. My total number of tickets sold is this guy right here. So what makes that up is students and adults. So x plus y is equal to 533. Now next, I can put all these dollar signs in one equation. So I'm going to say that 15 goes with my students. So 15 for every student. So 15x plus 27y is equal to, and my total number here for my dollar amount is 11,775. All right, so now I have these two equations, and what I have to do is solve them algebraically. All right, so you can rewrite these two equations down here. X plus y is equal to 533. And 15x plus 27y is equal to 11,775. All right, now you have to solve this algebraically by either substitution, elimination, doesn't matter. All right, I choose, personally, I like this one with elimination. So I'm going to multiply this top guy by negative 15 to get opposites here. So I'm going to go negative 15x minus 15y is equal to, and negative 15 times that is negative 7,995. All right, add these guys straight down. Since I have opposites, those cancel out. This makes 12y is equal to, excuse me, 3780. If I add straight down on these, that guy's a negative. All right, so if I divide by 12, I'm going to end up with my y being equal to 315. So y is equal to 315 adults. All right, and to solve and to find out what my x is, I got to plug this guy back in, so I can have x plus 315 has to be 533. So if I subtract 315, I get my x is equal to 218, and that is my students. All right, so I solved that word problem by elimination eventually, but I made some equations for myself here and here. All right, good. Awesome. Going on to number 4. This is the problem where it's going to probably take you the most work. So you really need to try here to keep yourself organized, to make sure you're watching your negatives, to go through here and solve. So here, always going to be really nice here. I'm going to give you a nice variable to cancel out. So here, if I look, I have these two guys are going to cancel each other out. So I'm going to have 3x plus 2y minus z equals 8, and I'm going to add that with negative 3x plus 4y plus 5z equal to negative 14. Add these guys straight down, those go away. I'm left with 6y plus 4z is equal to negative 6. All right, this is a z. I thought that was a 7 for a second. All right. Now, I did it once. I eliminated x once. I have to eliminate x twice. So if I look here, I see my 3x, my negative 3x, and my x. I'm going to multiply this equation right here. I'm going to multiply that by 3. Because if I do that, then I'm going to get opposites with this negative 3 right here. So let's write that one out. So I have negative 3x plus 4y plus 5z equals negative 14. This equation is going to be 3x minus 9y, because I distribute this onto everything here, plus 12z is equal to negative 42. Add these guys straight down, so now I get negative 5y plus 17z is equal to negative 56. All right. Excuse me. So now I have these two equations. I have 6y plus 4z is equal to negative 6, and I have negative 5y plus 17z is equal to negative 56. So again, if you were working this out on your own, you might have some different numbers along the way here, okay? But hopefully, if you did everything right and you kept all your negatives and kept all your numbers correct, you should end up with the same numbers, all right? Just some different numbers on the way. I need to eliminate a variable here, so I'm going to multiply both equations. This equation I'm going to multiply by 5. This one I'm going to multiply by 6. So I get my opposites and my y here. So I'm going to have 30y plus 20z equals negative 30. This guy is going to be negative 30y plus 17 times 6 is 102z is equal to, this times 6 is going to be negative 336. Add these guys straight down. My y's cancel out. I got 122z is equal to negative 366. And this is nice because you get these nice big numbers, but you end up dividing by 122, and that goes into there so nice. Our z is equal to negative 3. All right, so now what we have to do, and I'll make this a really colorful picture with all my colors here. I have -3 in for my z. I can plug it into either this equation or this. I'm going to plug this one because it just looks smaller, it looks nicer. So I get 6y plus 4 times -3 is equal to -6. So now I get 6y, and I'm going to add 12 over in this step. Is equal to 6y equal 1. All right, good. Found my x or my z and my y. Now I have to find my x. I'm going to go here. I'm going to pick out baby blue. I'm going to find here that this equation is probably the easiest to plug it into because x is all by itself. So I'm going to have x minus 3 times 1 plus 4 times -3 is equal to -14. All right, so now I have x, this is -3, this is -12, so this is going to be -15 equals -14. So now I add that 15 over, and I get x is equal to 1. All right, final answer here is 1, 1, -3. Make sure you give it to me as your final answer in that ordered triple there. All right, number 4, good problem, a lot of work there. All right, so keep going on here. We have number 5. It says graph the constraints. So I'm going to go through and graph these guys with some different colors. I have x is greater than 2, so that's going to be everything over here. It's a vertical line at 2, so this is Vux. All right. This line over here with my purple is going to be -4, 1, 2, 3, 4, and I have a 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. So that is that line. All right, and my last one, I'll do this in blue. I got to subtract this x over to get it in y equals mx plus b. So I have y is less than or equal to -x plus 8. So I have a y-intercept of 8, which is here. I go down 1 over 1, down 1 over 1, down 1 over 1 for my slope. Great. Oh, my guys didn't really intersect there. This should be that line. Excuse me. And most of the time, 99% of the time, it's going to be in the shaded region is going to be in here, okay? You can check that out for yourself. You can go through and say, hey, let's test 0, 0. So it's got to be everything greater than this line, got to be everything below this line, everything above this line, so you get inside that triangle. All right, so now it says find the ordered pairs that produce the vertices. So that is here, here, and here. So that point is 2, -3. The upper point there is 2, 6, and the last one is 8, 0. All right, those make up those side points, those corner points. All right, so here we keep going. It asks us to use those in the objective function to find our max and our min. So I have 2, -3. I have 2, 6, and I have 8, 0. And let's see which ones give me my max and min. So let's keep going. Let's go with this pink. I got 3 times 2 minus 4 times a -3. I get 3 times 2 minus 4 times 6. 3 times 8 minus 4 times 0. So these guys, let's find out what we got. This one is going to be 6. This is going to make 2 positives, so that's going to make positive 12. That's going to make 18. This guy is going to make 24 and negative here. 6 minus 24 is -18. And this bottom one is 24. Okay, so my maximum is 8, 0. And my minimum is 2, 6. All right, my min and my max. All right, good there, finding your max and your min. All right, awesome. Let's go on to the very last one, this great linear programming problem. I like to circle all my numbers. I'm going to need to use them. You guys can read through this on your own, but let's go through here and see what we got. So we got 18 cups. We got $3 per bag. We got all these great things. All right, 99% of the time when it says number, we're going to end up with just an X and a Y. So we're just arbitrarily saying, hey, let's call party mix X and table mix Y. All right, and it says that serial Check cereal. That says it takes 2 for the party mix, and then I add that X on there. Cashews have 3 for the party mix, and I go 1 checks for the table mix. All right, 3 for the table mix of the cashews. Again, you can go through here and you can read this to find out what these are, and then it tells me my limits here. Tells me that I have 18 things of Czech cereal, 18 cups, and 30 cups of cashews, and I profit $3 and $4. All right, so every single time there's pluses in here. These are most of the time less than or equal because these are our maximum, and then the bottom one is equal there. All right, so great, we have all these equations, but now I have to go through and graph them. So I have 2x plus 1y is less than or equal to 18. So I subtract that 2x to get it into y equals mx plus b. So I have y is less than or equal to negative 2x plus 18. All right, awesome. Now I go through here. This cashews is 3x plus 3y. Or excuse me, that is a 2. This is a 2 right here. Awesome. My bad there. Cashews has 2 cups for the cashews there. So this should be a 2 as well. 2x and 2y is less than or equal to 30. All right, and keep going on here. I got to get this guy into y equals mx plus b. I minus that 2x, so I have 3y is less than or equal to negative 2x plus 30. Divide by 3, divide by 3, divide by 3. I get y less than or equal to negative 2/3 x plus 10. All right, these two equations, I'm going to have to graph those using a scale of 2. So let's go through and do that. I have here, it says scale of 2, so I'm going to go 4, 6, 8, 10, 12, 16. All right, so this is 4, 6, 8, 10, 12, 14, 16. Says y-intercept of 18 for this guy. So that's going to be 1 above that. So there's 18. I got to go down 2 over 1. You can actually use these boxes. Okay, use the boxes since the scales are the same on the x and the y. This one's actually going to be halfway in between, so watch out for that guy. Perfect. There's that line. Awesome. Go to the purple. Let's see, I got 10 for that one. That's right here. I go down 2 over 3. I notice that that one's right on top of that one. So I go down 2 over 3. And then my shaded region is what's right in here. All right, good. So now I have to pick out those vertices of that feasible region here, 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 and here. Those 4 points that make up that side. All right, those vertices. So here, this guy is 0, 0 is most of the time 1. All right, this point actually right here is going to be 9, 0. So it's in between 8 and 10 here. So it's 9. This guy is 6, 6, and the last one is 0, 10. Right? Awesome. So now it asks me to test those in the profit equation. My profit equation up here is 3x and 4y. So I have 0, 0, 9, 0, 6, 6, and 0, 10. All right, test these guys in. I go through, find out which one gives me my maximum profit so I can find out how many bags of each I should make. All right, plugging them in, I get 3 times 0 plus 4 times 0 equal to 0. 3 times 9 plus 4 times 0 is equal to 27. 3 times 6 plus 4 times 6 is going to be 18 and 24, which makes 42. This guy's going to be 3 times 0 plus 4 times 10. That makes 40. So you can see here that this 42 is my max. All right. So now it asks you how many bags of each type will maximize your profit. This gives you your maximum. So it's 6 bags of party mix, 6 bags of table mix. And what is your profit going to be? 42 smacks. All right, 42 bucks. All right, so good. That practice test has a lot of only 6 problems, but it has a lot of really, really tough, long kind of processes here. So if you have any questions, please come find me, and hopefully I'll answer your questions. Thank you. Bye.